Okay, we have this. We have the technology. Okay, so once again, welcome to the Technical Assistance Webinar. We hope to answer any questions that you have. Of course, we are in the process of speaking to a lot of different groups and interested investigators who have contacted us. And so the purpose of this is to actually be fairly general. We can't obviously give specifics about anything, but we will be as cautious as we can, but give as much information out as we possibly can. I'm going to hand this over to my colleague, Young Rao, in one moment. He's going to go over the details in the slides in just 1 second.
Yeah.
One more second. Okay. Let me just... Okay, so is everybody seeing the slide sheet that says agenda? I'm hoping. Okay, good. So on this call, we're going to go over the background and purpose of the BICCN FOAs, give you a little bit of an overview of the 4 companion RFAs that are on the street. Then I'm just going to describe what we mean when we're talking about common brain samples and coordinate systems. We can go through some of the research objectives for each of the RFAs, and we want to amplify and let you know about the key dates and the funding that's available for each of these. So in terms of the background, many of you know this already. This is part of the BRAIN initiative, which we're being guided very much by the BRAIN 2025 report that came out a few years ago, and we are in the space of discovering diversity, and that is understanding the cell types in the brain. We're also very interested in mapping multiple scales, and we think this BICCN will address both of those. So brain cell types, the part list of the brain, as well as some of the connectivity and functional measures that can be achieved by understanding the brain cell types. So the deliverables as part of the report, we're hoping to get a census of brain cell types, again, the parts list, and also understanding the phenotype of different cells, meaning electrophysiology, potentially cellular anatomy, and connectivity, as well as some other endpoints as well. And we don't have to necessarily do all of those things, but we're interested in all of those things. And we think that this information will provide experimental access using both genetic and non-genetic approaches that help us define our own. Is there a question or? Oh, again, if I could just ask you all to put yourselves on mute if you're able to. So that's just a little bit of the background, and I'm going to hand this over to Young, and I'm going to work the slides for him.
So this is Young Yao, Program Officer. The 4 companion RFAs recently published about 1 month ago. And the purpose is to assemble a network of sensors and co-laboratories using scalable technology platforms and streamlined workflows to generate brain cell reference atlases that encompass molecular, anatomical, and physiological annotations of cell types in mouse, non-human primates, and humans. The central goal is to build a brain cell census resource that can be widely used throughout the research community. The resource includes both data and tools developed by the BICCN. So the BICCN will be composed of a group of U19 and U01 data generation centers and co-laboratories, and the U24 Center for data coordination, integration, visualization, and dissemination. Each data generation center or co-laboratory is expected to perform one or several 4 research themes that is molecular, signature, anatomy, function, and cell-specific hiding tools. The U24 brain cell data center will integrate, visualize, and disseminate the data generated by the BICCN as well as by the research community. The NIH expects that BICCN will operate as a cooperative network to promote collaboration and coordination with any research entities that have similar goals. A major deliverable in 5 years will be a comprehensive mouse brain cell atlas with data knowledge on the brain cell type, organization, and communication rules. So the two FOAs are for mouse brain cell census data tool generation. The RFA MH-17-225 U19 Comprehensive Center aims to generate a comprehensive mouse brain cell atlas by focusing on multiple research themes, while the U01 Specialized Collaboratory RFA supported by RFA MH-17-230 will have the same aim but focus mainly on one specific research theme complementing U19 centers. The human and the non-human primate brain cell census will be supported by RFA-MH-17-2210 U01 into accelerate progress towards establishing reference cell atlases of human brain and or non-human primate brain. And the data center U24 RFA aims to collect, curate, integrate, visualize, and disseminate the cell census data through a web-accessible data and knowledge base. So the two mouse brain cell census RFAs will require the use of a common mouse strain, C56 track of both sexes for the wealth of data available and its broad use in genetics and other studies to minimize source variability and maximize resource sharing. The brain cell census efforts of mouse brain will begin with adult animals, P56, and may extend to early developmental stages later in the project period if production throughput and the cost permit. The human brain U01 collaboratively supports the use of common brain samples from human and non-human primates. For example, postmortem healthy human brain tissue, but this outbreak does not require specific brain samples. The four companion RFAs embrace the existing efforts of the research community, for example, the International Neuroinflammation Coordination Facility, in short, INCF.
Where are you?
Could you mute, please?
So currently there's a AIHD great project growing company. I want you to come back to your computer and you can immediately what you need to do is to
excuse me, if there's a question, can participants please mute their phones because we are getting conversation?
Yeah, we can answer questions after this short presentation. So the four companion RFAs embrace the existing efforts of the research community that try to map all brain cell census data to common coordinate systems. But in analogy to the geographic information system, the molecular signature data, anatomical data, neural surface data, and the cell functional data will all be mapped to the common coordinate framework, so that all data will be spatially linked by set of spatial coordinates. The BICCN will promote common spatial and semantic standards to link heterogeneous data sets with EPNI expects that all brain cell sensor data will be spatially linked and widely accessible through a Google Earth or Google Maps-like brain cell access. The U19 and U1 RFA support data and tool generation research that most likely fall within the following four themes: molecular signature, anatomy, functional measures, and cell-specific targeting approaches and tools. For U19 sensor application, the U19 are required to cover at least two themes that are molecular signatures and anatomy. The U01 application can elect one theme focusing on the generation of one specific data type. As the goal is to generate a comprehensive brain cell reference data, the U19 sensors or U01 collaboration for mouse brain are expected to implement scalable technology platforms and streamlined workflows for the data and the tool generation in high throughput manner. The following research will not be supported by the U19 U01 sensors for the blockade. That includes studies of neural circuit diagrams at macro scale and or micro scale using magnetic resonance imaging and or electron microscopy based methods. Or studies of cultured cells, isolate cell samples, and or stem cell lines that are maintained under cultural conditions. And for the early stage technology development or tool development, there's another cell sensor brain initiative RFA-MH-17-220 that RFA supports the technology and tool development. And in particular, if people are interested in developing tools and technology specifically, I think this is a relevant RFA to consider. So the research objectives under the data and tool generation U19 and U01, since any efforts to generate an important and unique public resource following issues related to the large-scale data and tool generation are really important to the success of the program. So these are data quality, data comprehensiveness and completeness, data utility, and the production workflow. So each application needs to provide current estimates of data quality, and the plans for how data quality will be evaluated during the course of the project, and describe how to optimize experimental procedures to enhance data quality. Each application also needs to define comprehensiveness and completeness, that is breadth and depth for the proposed project, describing how close to that target the proposed project will get in 5 years. So the BICCN sensors and code laboratories are expected to abide by the agreed data sharing policy to ensure rapid data exchange and sharing. Each application is also to describe the production workflow, including throughput, and describe costs at the beginning of the project, identify large cost items, and the anticipated cost reduction during the project period. And the last, each application must also define a clear set of annual milestones with quantitative metrics to document progress and plans for critically evaluating and revising these milestones on a regular basis. To ensure the success of U19 and U01, each application is required to include data management and analysis activities, as well as administrative activities. For data management and analysis activities, the application needs to provide the center or core laboratory needs to provide local data storage, management, analysis, and integration, and coordinate data submission, standard registration, and visualization with the U24 data centers. For the administrative activities, the center needs to manage all aspects of the center or collaborative activities and foster effective interactions with other BICCN centers of laboratories. And tool and technology optimization could be included in the application. That's optional. And so if needed, the application can propose to support technology improvement, and that can include like throughput, data generation, analysis tool, and reagents, etc. So for the research objectives of the brain cell data center, the U24 center, and the U24 center will work closely with the other BICCN data generation centers and co-laboratories, as well as the broad research community, to establish a web-accessible information system for the brain cell assays. The U24 center will lead the effort to establish spatial and semantic standards for managing heterogeneous brain cell census data types and information. Lead
John, can I interrupt for a second?
Yes.
John, can I interrupt for a second? Yeah. So it took me forever to figure out. I don't know what the deal is with this call, but the option of muting was not appearing anywhere that I could find. But now I've noticed that if you go up to audio and the taskbar at the top of the screen and click on audio connection, everyone should have the option of clicking on the mute button on the built-in microphone, and it would be really great if they did that because the audio quality is horrendous.
Did everybody hear those instructions? If you could go to the audio tab and mute yourself, please. Thank you very much.
Thank you. So there are several functions and expectations for the U24 center. So the U24 center is expected to lead the effort to establish spatial and semantic standards for managing heterogeneous brain cell census data types and information, and lead efforts to collect and register multimodal brain cell census data to common brain coordinate systems, and to generate searchable 2D and 3D digital brain atlases for cell census data, and generate a unified and comprehensive web-accessible brain cell data and a knowledge base that integrates all existing brain cell census data and the information across diverse repositories. In addition to this data science effort, the U24 Center will provide the administrative infrastructure and function to coordinate both internal BICCN communication and external partnership, which includes plan and manage BICCN meetings, provide communication resources to enable discussion and report, and coordinate education and outreach efforts. So the final slide is about key dates and the funds available. And the key dates for letter of intent, due date is December 23rd, 2016, this year, and application due date is January 23rd, 2017, next year, and the earliest start date is September 2017. So for 201 RFAs, there's a second receipt date, that is October 13, 2017. Funds available and the anticipated number of awards. For U19 and the U01 mouse brain cell census, $80 million in total per year are allocated to funds 1 to 4 U19 comprehensive centers and 2 to 6 U01 specialized laboratories. And U01 human or non-human primate brain cell census laboratory, 5 million in total per year is allocated to fund 3 to 5 specialized laboratories. And U24 brain cell data center, so there's only one center that will be funded, and $3 million in total per year. And award project period is 5 years in maximum. So that's all about this 4RFA presentation. And if you have any questions, now we have time to discuss and resolve. Now you can unmute if you want to talk.
He's not out once, so.
This is Paul Austin. I have a question about the U01 collaboratory. One is to know where one will fit, but is it important to have and then official letter-wise their collaboration to fit with the centers? So even the applications that are writing the U19 centers?
No, that's not necessary. Each will be reviewed in isolation. It may be in your best interest to make a note in your application that you're willing to work with whoever will be funded ultimately, because of course nobody knows that ahead of time.
Right. Okay. My question. Thank you.
Any other questions?